Hello, Algebra 1 students. It is so good to see you guys today. I miss your faces so much. Today we are going to be talking about two different forms of the quadratic function equation. We're going to be talking about standard form and factored form. And I want us to remember that the power is in the connections. We're trying to build connections from the equation to the graph, and then how to get in between those two different forms. Before we get started, make sure that you've done the Desmos activity before you watch this video, because you're going to need that information before you come in here. All right, so if you haven't already done it, pause this video, go back into the module, do that Desmos activity, and we're going to go ahead and get started. So on that Desmos activity, you should have noticed something about the A value. All right, think about, what did you learn? What does the A value control about the graph? The A value of the equation. This A is being multiplied to the x squared. All right, you should have used that slider in the Desmos activity to notice that the A value controls two different things. One, it controls how wide the parabola is. So let me show you. As A gets bigger and bigger and bigger than 1, it's going to make a narrow parabola. And as A gets less than 1, it's going to make a wider parabola. All right, so one thing is it makes it narrow and wide. The second thing, so this is the parent function where the A value is just 1. But if we make A -1, what happened when A turned negative? Can you think back to that Desmos activity? Yep, it made it concave down. See, it reflects it over the x-axis, does a reflection, a flip, and it turns it from a concave up parabola that has a minimum to a concave down parabola that has a maximum as the vertex. So I wanted to remind you of that before we jump into our work for today. Now, these notes that I'm going to do with you guys, these notes, I think I need to restart this. All right, these notes that I'm going to do with you guys, they are on the module, and I have both a filled out version and a blank version so that you can go through this with me if you would like. All right, so let's take a look here. We have two different forms. We have standard form and we have factored form. Now let's make some connections. We're going to connect back to when we learned about linear functions. With linear functions, we had two forms. We had standard form and we had slope-intercept form. All right, now if you guys remember, these two forms looked like this. We talked about with slope-intercept form, it was a really awesome form because it gave us lots of information, like the slope and the y-intercept, or the initial value. It told us lots of things about the graph. We also learned about standard form. We said, hey, this is a great form for things like when we were talking about coffees and teas or hamburgers and hot dogs, but it doesn't tell us the slope or the y-intercept. So when we had something like standard form, we could rewrite it and change it into slope-intercept form. Remember that these are equivalent. These are the same exact equation, even though they sometimes look different. That's the same thing that we're going to learn about quadratic equations. So making those connections back to linear functions can help us out. We're going to learn about two different forms, and then how can we take this form and turn it into that form so that we can get some more information. So we already talked about how this A value is going to tell you, am I concave up or concave down? So I'm going to write this down for both of them. For the A value, if we have a positive A value, so I'm going to write positive A, all right, then it's going to be concave up, concave up. And if I have a negative A, then that's going to be concave down. Remember, concave down looks like a frown, and concave up looks like a smile. All right, so a positive A or a negative A, and this A is going to be out front of factored form. It's also going to be out front of standard form. It's going to be multiplied to the x squared, that leading coefficient. All right, we also said that that A value is going to make it narrow or make it wide. We'll get more into that later. All right, but if that A value is bigger than 1, you're going to have a really narrow parabola. And if that A value is less than 1, then you're going to have a wide parabola. All right, so this is what we know so far. We've got a concave up versus concave down parabola. So let's go through some examples. Hopefully you guys also learned about factored form and some special things inside here. I want you to notice that factored form means that it's factored. Factored means multiplication. So if it's helpful for you, you can draw little dots in here. This means multiplication. All right, it's a times this times this. But standard form is going to be adding and subtracting. All right, so let's keep moving. Let's look at this example right here and this example right here. These are equivalent equations. They both represent this graph. They are exactly the same. All right, and our question that we're going to be answering is which key features of the graph can you easily identify from each equation? So let's look at our key features on this graph and these two equations. If we take a look at these key features, I have some key features. I have an x-intercept right here at -3, 0. I have another x-intercept at 1, 0. -3 and 1, do those numbers look familiar? Can you see them in these equations? Let's take a look here. These factors have a 3 and they have a 1. But there's something that's different. What's different about this 3 and this 3? What's different about this one and this one? Their signs are opposite. Let's talk about why. When you take a look here, this -3 is the value that will make this factor 0. -3 plus 3 is going to give you 0. Let's try it over here. 1 minus 1 is going to give you 0. So these two values, these two x-intercepts are going to come from these factors. It's going to be, hey, whatever number is going to make this factor 0. So another word for x-intercepts, or that we learned about was also called zeros or roots. We can see that -3 plus 3 is going to make 0. And 1 minus 1 is going to make 0. So our two x-intercepts are going to be at -3, 0 and 1, 0. So we can now notice that from factored form, we can see these x-intercepts. All right, we can also see this a value. And we said this a value is 2. So let's look up here. Remember, for a values, if you have a positive a value, it's going to be concave up. So this a value out here, this value of 2, same thing, this value of 2, it's positive. So since it's positive, it's going to be a concave up parabola. All right, so that's why this one, both ends are going up. It is concave up because that a value is positive. Concave up because my a value is positive. Now let's look. We've got another number that I want you guys to notice here. And that is this number over here, this -6. This is going to tell us another key feature on our graph. So if you look at our parabola, do you see where -6 is an important number? Do you see where -6 is an important number? Take a look. All right, I think we found it. This -6 is our y-intercept. All right, so this -6 right here is going to be our y-intercept. All right, if you remember, let's make a connection way back to linear functions. All right, for linear functions to find the y-intercept, this actually works for every function, we plug in 0 for x. So when you plug in 0 here and 0 there, I plugged in 0. 0 squared is 0, times 2 is 0. 4 times 0 is 0. You're left with just -6. So my y-intercept is going to be 0, -6. So let's notice how we made some connections here. From standard form, I can see this y-intercept right here. All right. From factored form, I can see my x-intercepts from here, whatever numbers will make each of these factors 0. So let's add that into our notes. All right, so for standard form, we said this c value, we can see our y-intercept. Our y-intercept is always going to be 0, c. And then for factored form, we can see our x-intercepts. All right, some other words for x-intercepts are zeros. We can also call these roots or solutions. I know this is super confusing to have 4 words for the same exact thing, but these all mean x-intercepts. And those x-intercepts are going to come from these factors. And it's going to come from the opposite value of what you see. So here we saw a positive 3, but the root was at negative 3. And here this said negative 1, but the root was at positive 1. All right. So we're starting to learn about some connections. Let's go ahead and do a few more examples, and then we're going to come back and see how can we turn this form into this form. So I'm going to flip over to do example number 2. All right, example number 2. Oh, actually, let's go back. Let's learn because this one makes us do it. All right, so last thing we need to learn for this example is how can we take this and turn it into this? All right, now how we do that is by just following the operations here. This says 2 times this factor times this factor. We're just multiplying. So we have to learn how to multiply binomials. We have to learn how to multiply binomials. So we do this using an area model. It's kind of like distribution when we learned distribution earlier this year. So this term has 2 factors, and this term has, sorry, not 2 factors. This factor has 2 terms, 1, 2, and this factor has 2 terms, 1, 2. So we're going to make a box that looks like this, 2 by 2. All right, we're going to put these 2 terms here, and we're going to put these 2 terms here. We can put this on the side, this on top. You can switch these, that's okay, as long as one factor is on one side and the other factor is on the other side. We're going to multiply these first to make our lives a little easier, and then at the end, we'll multiply that 2 into everything that we have. All right. So let's take a look. How we multiply is we're finding the area of each of these boxes. You find the area by doing the length times the width. So let's do the easy ones first. This one's going to be the easiest one. I have negative 1, which is the length of this side, and then positive 3, which is the length of this side. So negative 1 times positive 3 is going to give me negative 3. All right, here I've got x and negative 1. When I multiply those, I get negative x. And then when I multiply these, x times positive 3, I get 3x. And then here, x times x. Now this is a tricky one. All right, let's jump back to remembering what we learned some things here. All right. So for example, if I do 5 times 5, we learned that this is the same thing as 5 squared. 4 times 4 is the same thing as 4 squared. So when we do x times x, that's the same thing as x squared. A lot of people think it's 2x, but let's talk about that. X plus x is going to give you 2x because this is 1x plus 1x. All right, but x times x is going to give you x squared, which is what makes it a parabola, because parabolas need that power of 2. Okay, so when I multiply this one right here, x times x, that is going to give me x squared. All right, so when we look in here, when we multiply these 2 factors together, we get what's inside of this box. Inside of this box. All right. We have x squared plus 3x minus x minus 3. All right. So I'm going to write that out. But before I do that, I noticed something. I see that we have two terms that are like terms. So just a reminder, remember if they have the same variable and the same exponent, these are like terms. So when we combine these together, 3x minus x, we're going to get 2x. So let's take a look here. When I combined all these together, I'm going to get x squared plus 2x minus 3, x squared positive 2x minus 3. I might even color code that to show that that diagonal was where this came from. Now this doesn't quite look like this yet. It doesn't quite look like this. Let's see why. Oh, I forgot this too. We've got to multiply this 2 out to every single thing. So let's go ahead and add this 2 out to the front. And we are going to remind you, we have to distribute that 2 to every single term. Every single term. So I get y equals 2 times x squared gives you 2x squared. 2 times 2x gives you 4x. And 2 times negative 3 gives you negative 6. Now we can see that these are equivalent. All right, I took my factored form. I multiplied these factors, then distributed the 2. And what I got was my standard form. These are equivalent. So one more kind of overview of this example. From factored form, I can see that my equation is concave up because I have a positive a value. I can also see my x-intercepts. Negative 3, 0 is what's going to make this factor 0, and positive 1, 0 is what's going to make this factor 0. In standard form, I can also see that it's concave up because we have this positive a value. And finally, I can see the y-intercept. All right, so this y-intercept you can see in standard form, the x-intercept you can see in factored form, and you can turn factored form into standard form by just multiplying using the area model and distributing if you have an a value in the front. All right, I've got a few more examples for you.